Hello everyone. Uh, in this session, we will see about topics of analog and digital conversion techniques. Okay, so let me specify that. So analog and digital conversion techniques. So when we go for this analog and digital conversion techniques, first thing is what is the necessity of going for this analog and digital conversion. So the very first thing what we can understand through this is in some related aspects we may have the input data in the form of an analog version, but the system what we are using it may be a digital system. Okay, means the input may be an analog, but whereas the system for the transformation of data it is in the form of a digital. At that moment, you have to convert your particular analog signal into the digital signal. Similarly, we can also come across there may be an digital data, and whereas the system what we are using will be in terms of an analog. Then at that moment, you can take the digital to analog conversion techniques also. Okay, so in this analog and digital conversion techniques, if we see, then we may come across different types of conversion scenario. So it means there is a possibility that we can have the first thing is in some cases we can go for analog to analog conversion. Okay, so this is in one way. There may be a system with analog input, and we must have the conversion to be also we need in terms of an analog. So in that terms, we can take the analog to analog conversion process. So this is one way what we can take in the analog to analog conversion mechanism. Okay, and next we may have the analog to code. Okay, so means the input what we are having, so that may be in terms of an analog. Okay, so and the output what we are going to consider, so that we will be getting in terms of some discrete related way, so that we can take analog to a discrete form. Okay, so analog to discrete conversion will also be we can observe whenever we are going for this analog and digital conversion mechanisms. So first we may be ready to see this analog to analog based conversion, and we may also see analog to discrete type conversion things. Okay, and next the third mechanism what we are going to see is that is analog. Okay, so whenever we are using this term analog means that says that we are using some particular waveform, right? So we are taking the waveform. So when we use this term of a waveform, then so now this waveform is to convert to code. So analog to, okay, code conversion. Okay, this is the third method what we are going to see in our conversion process. So one is in terms of an analog to analog conversion mechanism. And next we may have to see analog to discrete conversion mechanism, and we may also see analog that is a waveform to code conversion mechanism. And next there is a possibility next we can take that input in the form of a discrete. Okay, so now the possibility what we are having is our input is now in the form of a discrete, so where we can take the input in terms of a discrete. So now I can specify it as that is input instead of discrete. Okay, so let me specify it directly in terms of a digital. So let us take the term that is a digital means binary data now I'm having. So now this digital, I want to convert it to analog. So that is the another process what we can take. So that is digital to analog conversion. Okay. So when we use this type of conversions, and in some cases, there is a possibility of digital to digital conversion also. So that is the one more type of conversion what we can expect in the real-time applications, that is a digital to digital conversion. So these are all the possibilities in analog and digital conversion mechanisms. So either we can perform all these different types, that is analog to analog conversion we can do, analog to discrete conversion we can do, analog to, that is code conversion we can do, and analog to, sorry, digital to analog conversion we can do, and we can also go for a digital to digital conversion. Okay. So in all these terms, whenever we are going for this conversion mechanisms, we are using certain modulation techniques. Okay. So when we are going to perform this conversion mechanisms, in each type of conversion what we are using, we are going for considering the different modulation analysis in all these types of conversion mechanisms. So here, suppose the first process, what if you take the first methodology, that is for the analog to analog conversion. Okay, if I take this first technique of analog to analog conversion, then in the analog to analog conversion, which type of modulation techniques are used? Okay, so let us take the first one, that is analog to analog. So if I go for this analog to analog conversion, then in this, so we are now coming across the type of modulations. Okay, so if you go for this analog to analog conversion, and if you are checking for the type of modulation during this analog to analog conversion mechanism, which type of modulation techniques are used? Okay. So which type of modulation techniques used? So all the basic terms that what we can take, that is here in the analog to analog conversion, we can come across two types of modulation techniques, that is simple baseband and as well as the continuous. So baseband transmission what we are using, that is we can use for the shortest distance communication, and continuous wave modulations types are used. Okay, so we are going to take the type of modulation what we are using. This type of modulation, we are going to consider it in terms of a continuous wave modulation. Okay, so we are going to take the modulation term in terms of a type of modulation. So I am specifying this type of modulation as a continuous wave modulations. So continuous wave modulations are used. So in this continuous wave modulation, we are having three different types of continuous wave modulation. So in this continuous wave modulation, we can expect that we can perform the amplitude modulation, that is our AM. Okay, so we can perform this amplitude modulation analysis, and we can also go with the frequency modulation and as well as the phase modulation. So all these three types of modulation techniques what we are using, that comes under the concept of the continuous modulation. So amplitude modulation and frequency modulation and phase modulation. So these are the three different modulation techniques that are used whenever we are going for this conversion of an analog to analog based, in that which type of modulation techniques are comes into picture in the sense. So you can take this type of the modulation. So all these three modulations, we can consider it as a point of a continuous wave modulation. Among this continuous wave modulations, we are using this type of modulation techniques for the analog to analog conversions. Okay, and next, suppose the type of modulations what we are going to use whenever we are going for the second term. That is, if we are using the second type of conversion, that is analog to discrete. Okay, so when we go for this concept of analog to discrete, so here, when we use this term analog to discrete, in the sense the carrier signal, it is a continuous form there we used, and now coming to this type analog to discrete, here the carrier signal, it is in the form of a pulse. Okay. So continuous wave modulation represents what? The thing here, continuous wave modulation, it is representing in the sense you can take that this is the meaning for this continuous wave modulation. What is it specifies? In the sense you can say that carrier signal is in a continuous, carrier signal is a continuous sine wave. Okay, so that is the meaning what we can take our carrier signal what we are using. So this carrier signal is a continuous sinusoidal signal. Okay, so that is the meaning here, continuous sinusoidal signal. So that is what we can take in the transmission part for the analog to analog based versions. We can use this continuous wave modulation. Meaning of continuous wave in the sense the carrier signal what we are using, it is in a continuous form. That is a continuous sinusoidal signal. Okay. So now if we come across this concept, that is analog to discrete. So in this analog to discrete, if we are using the type of modulation techniques in the analog to discrete form, when we are going for this time, then the type of modulations. Okay, so here if we go for the type of modulation techniques used. So in this, if we are using the type of modulation techniques here, once again we have to take instead of the continuous wave modulation types, here we are going for the pulse wave. Okay, so means we are taking the pulse wave modulation, means we are using this concept of carrier signal in terms of a pulse. Okay, pulse wave modulation. So when we take this concept of the pulse wave modulation, then we can say that in pulse amplitude modulation, we can expect this type of an discrete related waveform representations are going to make. Okay. So if we are taking this pulse wave modulation, the meaning for this, if we specify what is the meaning for this pulse wave in the sense, the simple thing what we can expect is carrier signal is in the form of a pulse. Okay. So carrier signal, whatever we are using, this particular carrier signal is in the form of a pulse. Okay. So that is what we are going to get in the form of pulse. It's what we are going to use. Okay. So based on this particular carrier signal that is in the form of a pulse, we are going to define this pulse wave modulation techniques in terms of three different aspects here also. So based on that pulse related techniques, we can use the system as the modulation techniques as that is a pulse amplitude modulation. So we will be using this modulation technique, that is pulse amplitude modulation. And next we are having pulse width modulation. And we are also having the pulse position modulation. So three types of modulation techniques are used. One is pulse amplitude, another one is pulse width, another one is the pulse position modulation. So three types of modulation techniques that are used during this particular conversion process of an analog to discrete based. Okay, and we are having the next thing, that is the third technique what we are used, that is a waveform to code conversions. Okay, so this type of technique, that is a third related techniques that what we are using, that is we can call it as the waveform coding. So we can call a waveform to code. Okay, so waveform to code related aspect. So when you are using this type of conversion, waveform to code, then here in this, if we are coming with the type of modulations that what we are using. So if now coming with the type of modulations techniques used in this particular conversion process, if you go, then which type of modulation techniques are going to be used. So that we are going to see now. So in this, we are coming across the different modulation techniques, because the input here it is a waveform, whereas the output what we are using, it must be getting in the form of a code. So now the waveform, the modulation techniques what we are using, so we call such type of modulation techniques as waveform coding techniques. So waveform coding techniques. So in this waveform coding techniques, we come across the different types of waveform coding techniques. So one, you can specify it as the standard one, that is your pulse code modulation. That is your PCM. So pulse code modulation. So for this pulse code modulation, we can see that the input is an analog form, whereas the output what we are getting, it is in the form of a code. And next, we are also seeing that the another techniques that we are having is the differential pulse code modulation. So this is another modulation techniques that what we can use, that is differential PCM, that is differential pulse code modulation. So here can simply write it as a PCM. So now it means here we can take the difference between the data transmission that is happened between the first sample to the second sample, and we can take through the difference. You are going to send the information, that is your quantized information. So by using this differential PCM, we can come across that the bandwidth is utilized properly. Here pulse PCM, it requires more bandwidth. Then we are going to come across the reduction techniques in the bandwidth. Among the reduction techniques, different types of techniques comes into picture. So all those things are using the same aspect of waveform coding, but why these many techniques comes into picture is based on the aspects of noise reduction, and as well as the second related aspect what you can take it will the bandwidth reductions. Okay, so that is the one more thing what you can take. And next, coming with the next method, the one is pulse code modulation technique, the second one is the differential pulse code modulation technique. And next we come across the next method, that is we are having the adaptive differential PCM is also there. That is another technique, that is adaptive DPCM. So we call that is adaptive differential pulse code modulation. So this we can simply write it as a DPCM. Next we are having the third technique as the ADPCM, is adaptive differential pulse code modulation technique. And next we are coming across the one more method that is called as a delta modulation. So this is also comes under the waveform coding techniques, is delta modulation. So we can name it as a DM. And next we, with respect to the delta modulation, we are also having one more technique, that is we can use it as the ADM, that is a adaptive delta modulation. So the another thing that what we can see through this is the ADM technique, that is the adaptive delta modulation. So I can simply So I can simply write it as the ADM. So adaptive delta modulation. Okay, so these are the different things that what different modulation techniques that what we can expect through this waveform coding analysis. Okay, so pulse code modulation, differential pulse code modulation, adaptive differential pulse code modulation, and then we come across the delta modulation and then adaptive delta modulation. So all these are the things that what the modulation techniques we are using in the waveform coding techniques. So these comes as the waveform coding techniques or waveform to code. So the next thing what we can see regarding the next conversion what we used here, that is digital to analog. So when we are coming with respect to this digital to analog mechanism, so that is digital to analog. So in this digital to analog techniques, so we are using the conversions that are passband modulation techniques are going to be used. So the modulation types of modulations. So here if you take the types of modulation, so the types of modulation techniques used. So here you can expect that here we are coming across this, that is the passband modulation techniques. So passband modulation techniques are going to be used. Okay, so what are these passband modulation techniques? In a sense, we are having that shift keying techniques. So we can call it as the shift keying techniques. So in this, we can expect that this passband modulation, suppose the first one what we are expecting, that is your amplitude shift key. So this is the first thing that what you can take is amplitude shift keying, that is ASK technique. And next we are having second one is as the frequency shift keying. Okay, that is the second one, that is FSK. So frequency shift keying technique. And next we are coming across this PSK, that is phase shift keying technique. This is the third one, phase shift keying. And next we are having one more thing, that is differential phase shift keying, that is DPSK. So I can simply call it as the differential PSK. Okay, that stands for the differential phase shift key. So this we can specify it as the ASK. So this we can take it as an FSK, and this you can take it as a PSK, and next you are taking it as the DPSK, that is differential phase shift keying techniques. And we are also having one more term, that is your quadrature phase shift key, that is your QPSK. So quadrature phase shift key. So I can call it as a quadrature PSK. So where you can abbreviate it as the QPSK. Okay. So where the difference between these all the things that are going to carry the binary information. So we are giving the input in terms of the binary data. So that's why these are all named in terms of a BASK. So they are being abbreviated in terms of a BASK. That is, we are dealing with respect to the binary data, that is input in terms of a binary you're applying, and you can also call it as the BFSK, okay, binary phase shift keying. and we can also call it as the BPSK, binary phase shift keying. Okay, and these are the things, and this will be differential phase shift key, and this will be the QPS, quadrature phase shift. So the basic difference between in the practice, so okay, the basic difference between this BPSK and QPSK is here you are going to take 2-bit transmission, whereas here you are going to take the 1-bit transmission for at a time. So that we will see in the topics related with the QPSK and BPSK explanation part. So, and here the thing what we have to understand is when we are going for this passband modulation techniques, we are always taking the input in terms of a binary, whereas the output what we are getting, that we are seeing the variations of the carrier signal what we are using in terms of an amplitude, in terms of a frequency, and in terms of a phase. So that we are going to see, so that the output that what we are going to get, what we are expecting, that will be in the form of an analog version. So that is what you can take it as a digital to analog conversion mechanism. Okay. And next, we are also having the next technique. So when we come across the next technique, that is our digital to digital conversion. So when we come across this digital to digital conversions here, so in this digital to digital conversions, we are going to consider the different coding aspect, means whether you are following here we are coming across this concept of line coding mechanisms. Okay, so line coding mechanisms are used instead of this modulation process. Okay, so line coding techniques are going to be considered whenever you are going for this digital to digital conversion. So line coding techniques are used. So this is what we can take whenever we are going for this digital to digital analysis. So this line coding techniques, in the sense how you are representing your binary data in the form of a waveform, okay, in the form of a pulse related wave. So in this, if you take the line coding mechanisms, so in this line coding mechanisms, you can take the different versions. That is, we may have unipolar RZ. Okay, so unipolar RZ. So, and here RZ, it stands for return to zero. So return to zero. And next we are having bipolar or polar RZ. So that is the another line coding technique. And next you may have bipolar NRZ, non-return to zero. Okay, so that is non-return to zero. And we are also having a Manchester coding. Okay, so Manchester coding techniques. And we may also have the differential Manchester also in this. So Manchester coding, differential Manchester coding will also comes into picture. Okay. So in this way, you can take this type of a line coding mechanism process for this digital to digital conversion. Means suppose here the simple thing, whenever we are taking this transmission of the data, then we are going to take how you are representing it. That is the most important thing. How you are representing the particular data in terms of a waveform. So that is also important. So here the one more method I can right? That is differential Manchester. So differential Manchester. And there will be some more codings like 2b4 codings also there. Okay, so all different types of coding things what we are coming across here. So that is going to specify that how we are representing a particular code. Suppose if we take simply, suppose if this is a data, let us take that. Suppose if I'm having 101101, this is some binary data. This, if you want to represent it in terms of a line coding, so if you want to take only unipolar, that is only on one direction term, then return to zero process, then we will take the positive value, that is a positive V. So whenever the voltage, whenever the bit value is one, it is at the maximum voltage, and so whenever the bit value is zero, then it is at the zero level. So means it is representing at zero. So this is what we are going to see in terms of the general our unipolar based. Similarly, you can take the bipolar version, that is from positive value to the negative value, and then you can represent it in terms of a bipolar part. So likewise, you are going to specify a different ways of line coding techniques whenever you are using this concept of the digital to digital or digital to digital conversion mechanism. So when in this digital to digital conversion mechanisms that what we are using, so we come across this types of the line coding mechanisms that what we are going to consider. Okay, so this is what the different conversion techniques we are having, and at the same time the different modulation techniques that what we are going to use. Okay, so this is the analog to digital, so analog and digital conversion techniques what we are using. So among the different techniques, this will be the different ways of analog to digital conversion techniques we are going to use, and this what are the different types of modulation techniques that we are considering. So that is what we come across through this concept, that is analog and digital modulations. So why these many modulation techniques comes into picture in the sense, because we are performing different types of conversions. So based on the different types of conversions what we are using, we are coming across this methodology of which modulation technique should be used at which. Similarly, there is in the analog to analog conversion, we can also take the baseband. Here we use the continuous wave modulation. There is a possibility of taking the baseband modulation. So all baseband modulation techniques will also comes under this analog to analog. But there we are not using any related modulation techniques are used. They will be directly transferred for the short distance communications. As we know that modulation are performed when we want to send the information for maximum distance related aspect. Okay, so so in this lecture, this is the thing what I'm going to what I just going to cover. So I covered so through this analog and digital conversion techniques. In the next lecture, we will discuss about all these different modulation techniques and their related operations, how they are going to perform the operation, and which type of modulators, how that modulators are executing their particular functionality. So that we will see one by one in the next coming sessions. Okay, I hope that this information will be very much catchy for you, so that I'm expecting that this is understood. Any related queries you are having, you can put it in the comment box. Thank you.